Hi everyone, welcome to another Q&A video. In this video I'm going to show you how to publish a command vel, more specifically a navigation goal, using the MoveBase ROS package. I found this question on ROS Answers, in which the person is wondering how the command vel is published within the MoveBase package. He's already set up all of his .yalms in here, so everything is good. And he's just wondering how to publish this command vel that is sent out to the robot. So to do this, I'm actually gonna go into the construct and do the example there, so you can see how it's done. It's the constructsim.com. We're gonna log in, and once we're in, if you don't have an account, you can make one. We're gonna go to my ROSject over here and create a ROSject. There we go, and in this red button, we can create our ROSject. So we're gonna set it to ROS melodic. Name, we're gonna name it MoveBase example. For any name is okay. And a description. This is an answer to ROS Answers question about MoveBase. There we go. Make it private and create it. And right here you can see that it's been created. So we're gonna go ahead and run it. While it's loading, let me take you back to the constructsim.com, which is a great resource for you to learn robotics, anything from ROS. There's over 50 robotics courses, including navigation and things like mapping and things related to this question, where you can learn anything. It doesn't matter if you're a beginner or an advanced programmer. You guys should check it out, create an account, and start learning. So over here we see that our ROSject has been opened, and over here we're going to open a web shell on the bottom left corner, and we're going to clone some repositories. We're going to use the example that I always like to use is the Turtlebot, because there's already a bunch of packages that you can use and you don't have to worry about configuring them. You can see how the things work there. So for that, we have to clone 3 things. We're gonna go to GitHub, and this one is the Turtlebot 3 packages that we need. So it's Robotis is the company that makes it, so it's Robotis Git /Turtlebot 3. So this is the first one. So we're gonna hit on this green button and clone. Here you can copy this address, and we're gonna go back to our web shell and enter our simulation workspace. So we're gonna hit cd simulation workspace, and inside our src folder. So once we're here, we can just type in git clone and paste what we just copied on the other website. And there you go, it'll clone it into our workspace. So we're gonna do that 2 more times with 2 other repos. The second one, is called Turtlebot 3 simulations right here. So the same thing as the other one is just underscore simulations added. This includes the simulations that we're going to be using for Gazebo. So the same thing, you want to copy it. We'll go back to our web shell and clone it the same way. And the last repository to clone is called Turtlebot 3 messages. So it's right here. Same thing, just instead of simulations, it's messages. So hit that green button, copy it, go over to your web shell, and clone it the same way. So there we go, we have our 3 repositories now. So next thing we want to do is compile and source our workspace. So we're just going to hit cd ... to go back and compile with catkin make. Alright, so now that we've compiled, we're going to source with the command source devil / setup.bash. And finally, the last command we need to send is ROS pack profile. There we go. Now we're ready to launch our simulations. So the first thing we're going to do is launch the gazebo. So in this same web shell, you can specify the Turtlebot model that we're going to use. For that, we're going to type in export turtlebot3 _ model equals burger. There we go. And we're going to launch our simulation. So ROS launch turtlebot3 _ gazebo. And the name of it is called turtlebot3 world.launch. So this is going to start our simulation. To see it, we're going to go to this button over here, the gazebo button, the simulation button. You want to click it and wait a little bit until the simulation starts up. There we go. We have it right here. And so we can start launching our navigation packages. So if we want to autonomously navigate, we want to first map our environment. And to do that, we're going to use a provided package that the Turtlebot repository already has. So we're going to go ahead and launch it. In another terminal, it's always useful to just export the Turtlebot model. There we go. And we're going to launch our mapping package, which is ROS launch turtlebot3 slam turtlebot3 slam.launch. So we launch it, and you can see how it's already starting to scan over here. And to see what it's doing, we're going to go to the graphical tools button, this one that looks like a computer down here, and click on it. And what this is going to do is open Arvis. There we go. Sometimes it's good to hit on this button so it kind of resizes to a better location. And there we go. You can see that it's already starting to map. So we're going to have to move around to complete this map. And to do this, it's easy enough. We are going to open up another web shell. And like always, export our Turtlebot model. And launch our teleop package. Well, the package that is provided by Robotis in the repositories that we cloned. So ROS launch turtlebot3 teleop turtlebot3 teleop key.launch. So we're going to send that, and to be able to see everything, I'm going to resize everything a little bit. this is pretty good. And we're gonna use these keys to move our simulation around and to map. So we can start hitting W and you can see how it's starting to move. So we're just gonna navigate through the map in order to build the map. So as long as you have a reasonable map, we can use it for MoveBase and the navigation package. So there we go, it's almost ready. I'm just gonna go around here. There you go, we're gonna stop it with S. And there you go, we have our map. So we're gonna save it. Thankfully, we have a tool for that. So open up a new web shell and just type ROS run map underscore server, map underscore saver, hit enter, and you'll see that it outputs writing map occupancy data to map.pgm and to map.yaml. And to see where it saved it, if you don't write anything, it's just gonna save it in your home. So if you hit this button, the code editor, it's gonna open the IDE. And there you go, you have it on your home, these two files that we just saved. So we're gonna use this for the MoveBase package. So now that we have this, we can go ahead and stop our mapping package. And it's fine, RViz will go away because we're not mapping anymore, but we're gonna launch our MoveBase package. Well, our MoveBase and another one that is complementary called the AMCL that is in charge of localizing the robot. So we're gonna type in ROS launch Turtlebot 3 navigation, Turtlebot 3 navigation.launch. So this is again provided by Robotis. I'm gonna hit enter. And here you see that the nodes that is launching, one of them is the AMCL I talked to you about, and the other one is important one is MoveBase, the one that the person was asking about, how it sends the velocity commands. And you can see that RViz opened up something else, a new configuration that is provided by that package we just launched. So the first thing to do is, as you can see, this is kind of out of phase. The readings that the Turtlebot is making and laid on top of the map. So the first thing we want to do is look at where in the simulation the Turtlebot actually is and sort of try to set our initial position close to it. So as you can see, it's over in this corner. So to set our initial position, we want to click on this green button called 2D post estimate. Just gonna make this a little bigger. So we hit it, and as you can see, it's around this corner pole over here, and it's kind of facing towards the center top. So we're just gonna click and hold and kind of point at where the Turtlebot is looking. So there we go. And you can see how it kind of starts to align itself. So, and this is where the question is answered. How does the MoveBase send the command velocity in order to arrive to a goal? And that's the way it does it. It looks at a goal that you specified, and using the localization and internal algorithms of AMCL, it's going to start sending the Turtlebot 3 this command vel that is necessary to reach your goal. So to do that in RViz is really easy. We can hit this 2D nav goal button on top, and we can just send it wherever we want. So let's say we want it to go over here, and if you hold it, you can specify the orientation that it's going to end at, the Turtlebot. So we can just say that it's going to look this way. And you can see over here how it's making the local planner and the global planner in order to arrive to that goal. Sometimes it takes a little bit for it to start going, but eventually, once these green particles that you see that are actually tiny green arrows start to converge, there you go, you can see how it's starting to converge around the Turtlebot, which means that the localization is getting better and better. So that way, the move-based package can now publish this command vel in order for it to reach the goal. So you can see how it's, approaching the goal. And another way to visualize this that is very useful is the RQT node graph. So I'm gonna show you that real quick before I let you go. So there you go, you can see how it arrives to its goal, and then it's gonna it's gonna point in the direction. So there we go, that's move base for you. And we're gonna look at this node graph that I'm telling you about. So you can open up a new web shell and just type in ROS run RQT_graph, and then again RQT_graph. And if you don't have it open, just hit on the graphical tools button, and you can see how RQT over here opened. So we're gonna make it a little bigger so we can see what it's inside. There you go. So this is a great tool in order to see what node is communicating with what node, and what are the topics that are being used. And I just use it all the time to just kind of get an overall picture of what my system is doing. So here you can see how this is the main node, the move base package, and it's sending out a command vel to Gazebo, which is our simulation. And in real world, it would be the actual robot. It wouldn't be Gazebo. And from this, Gazebo can then send back an odometry topic, and this makes the makes the move base to update the command velocity it's going to send based on the goal. So this is the process that it goes. So it goes move base, command vel to Gazebo, and then returns the autumn to the move base. And over here is the AMCL node that I was telling you about, that is represented by those little green arrows. So that is basically how command vel is published to a robot using move base. You have to provide it with odometry coming from the robot and with AMCL as a supplement, and that way it publishes the necessary velocity commands in order for the robot to achieve the goal that you've specified. And actually in the ROS Wiki website, there is a really good tutorials on navigation, on the navigation stack, which is what move base is included in. So in this image, as you can see, there you go. This is the move base inside this square, and what is outputting to the base controller is this command vel that I was telling you about. And it goes through a local planner and a global planner, as well as the cost maps, local and global, that you specified in those .yaml files. And over here, the AMCL, which is in charge of that localization by publishing transforms to the move base and communicating with the move base package. So there you go. I hope I answered your question. This is a great first package in order for you to start doing autonomous navigation. And yeah, guys, I hope this was useful. I'll see you guys next time. Bye bye.